All right, guys, here's number 3 of 2009. So if we're looking at this, they give us a graph. So we're dealing with a continuous function. You can see that it's continuous. There's no breaks, and they kind of tell you all this information. They kind of give us the information about the graph. You just got to kind of pay attention to little things like at a curve that is tangent to the x-axis. So just make sure that you kind of realize that they're giving you hints tangent to the x-axis at 3. What does that mean about that? That means that the derivative is equal to 0 right there. So make sure you understand that that's going to be a key point. When they give you information, that's going to be a key point in one of your answers, okay? So on the interval between 0 and 6, only from 0 to 6. So they're giving us a small piece of information from here to here, right? The function is twice differentiable, meaning I can find f double prime, okay? And it's saying it's greater than 0. So we're talking about concavity there. So now, when we're looking at this piece here, let's just kind of grab this. Is f differentiable at 0? So now we got, even though it's continuous, remember we got to have this is testing differentiation. We have 3 conditions. Look up those 3 conditions to find out if it's a differentiable. 3 conditions, and you have to use the definition of a derivative. So this one key piece here is your definition of a derivative. And then you're using one-sided limits. All right, so I want you guys to really pay attention to this piece. This is a concept we went over. This is a separate concept we went over. And this is a third concept we went over. And all of them are now tied together. So you have to do one-sided limits. You got side A and side B here. You've got to do one-sided limits using the definition of a derivative. So look that up. And then once you do that, it has to satisfy the 3 conditions. So make sure it's almost like you're working from the left towards the right, okay? Now for B's a little bit different, but we're still sticking with the definition of a derivative. They changed it up on you. They said, oh, let's do the average rate of change. Remember, the definition of a derivative is literally the average rate of change at a given point. So make sure that you guys don't get thrown off by the wording, okay? Average rate of change is the definition of a derivative. Okay, and so they want you to find that spot. So now what they're asking you is, where is it equal to 0? All right, so you're going to go back up using the average rate of change and find those spots. You can see how many spots. Look, there's 2 spots right there. That's where it's going to equal 0. So now let's see what you can come up with in finding those answers. And then they're between, excuse me, I don't know why I wrote that one in there. Now, C goes to the next extreme. It says for the mean value theorem. Okay? So basically, you're asking yourself this. Where are these answers at? Where are the answers in B at? And does one of them fall on a certain interval? Okay? So those are the key pieces here. So where are those answers at? And where is that answer going to be? 1/3. So we're going to use some of the information here to answer this piece. Excuse me. This piece here, because that is kind of you're setting yourself up to be able to answer C there. Now, excuse me. I'm starting to get ready to cough. Part D is a little different. It's theoretical. You're going to have to relate g of x. Let me rephrase that. You're going to have to relate g prime of x to another function. And then you're going to have to relate g prime prime of x to another function, okay? They mean something. And then they want to know where something is concave up. So we've got to go back to our first and second derivative rules and figure out what makes it concave up. What makes it concave up? So they're asking you to justify some things where it's going to be concave up, okay? So make sure that the justification is extremely crucial, where these rules, what makes it concave up, using g of x. Now remember, g of x is right here. G of x is the integral of this. So we're dealing with the fundamental theorem of calculus again. So make sure that you understand about what this is saying. So again, we're dealing with the fundamental theorem of calculus. And so look that one up. That one gets a little tricky sometimes. So those are the things for number 3 on 2009. I will do number 5, and hopefully this is getting you guys steered in the right direction.